How's it going, 7th graders? This is Mr. Miles coming at you with a podcast, and this one is dealing with Earth in space. Earth in outer space, to be precise. Earth in space. Now, we're going to be talking first about Earth movement. So how does the Earth move? How does it move? There's actually two ways, and you guys remember it can move in either rotation or revolution. Later in life, you'll find out that those aren't the only two ways. There's other ways, but these are the two big ones that we're gonna, that you see and notice. Now, rotation and revolution. Let's talk about the first one. Let's talk about rotation. What rotation is here we have our Earth, and there's a pole. So there's our North Pole, and then back here, because you can see it's in the front, it'd be back there. It'd be the South Pole. Now, as it spins like this, as it spins on itself, like if you were spinning a basketball on your finger, we call this a rotation. Now, these points, the north and the south point, what we call those axis. Now, an axis serves as a point where that it would spin on. So if you had that ball spinning on your finger, so here's your basketball. There's your finger, and there's your stupid smiley face. Boy or girl, long hair, a hippie boy, maybe. And as it spins, this point right here would be called the axis, just like these would be called the axis too. So that's a pretty simple concept. Now, that's not the only way that the Earth's going to spin. So not only is it spinning in this direction, but it's also going to be following an orbit around the sun. Of course, here's our sun with his awesome sunglasses and his big smile. And so as it follows this path going around the sun, what we call this is simply a revolution as the Earth spins around it. So again, really simple. And the other term you use for it is we call it an orbit. So it's rotating and it's revolving. It's going through a revolution around the sun, and we call that being an orbit. Now, the next thing we're going to run into is there's a very special thing about how the Earth rotates and revolves, which causes seasons. Remember, we talked about, and I asked you, what causes seasons? And some people said it has to be distance. So if it's closer to the sun, it's going to be warmer. If it's further from the sun, then it's going to be colder, right? And again, that could make sense, and I can see the logic behind it, but then there's a problem, because if here's the Earth and it's close to the sun, so you'd expect it to be warmer, so you'd expect it to be summer. But wait a second. In the southern hemisphere, when we have summer, they have winter. So that doesn't make a whole lot of sense, because the summer and then the winter are the same. And then why would the daylight change? Because in the summer you have longer days, but in the winter you have short days. And that doesn't make a whole lot of sense. Why are we shorter? Like, maybe it would be, you'd expect it maybe to be dimmer, but you wouldn't expect the sun to set any sooner, because it would just look the same, right? Well, that's correct. There's a problem here. And the reason is because it has nothing to do with distance. Actually, in the northern hemisphere here in Vegas, we are actually closer to the sun during winter than we are during the summertime. What's really causing this is how the Earth tilts. We have a tilt in the Earth. So here's our North Pole, here's our South Pole. And because of that, it affects how the sun hits the Earth. And remember, we did that little thing with the flashlights, and you shone that flashlight on the piece of paper directly on, and you got a beam about this big. But then when you shone the flashlight on it, you got a beam that was that big. Okay, sorry, let's make this easier. Okay, so you got a beam that's this big, and then when you shine it on an angle, you get a beam that's that big. So the energy is actually being dispersed. The energy from the flashlight is being dispersed, and there's less of it. And remember, there was the thing I talked about with the magnifying glass. And with the magnifying glass, I said what you're doing is you're simply taking something about this big. You're taking this much sun energy, and you're harnessing it down to a point about this. So you think about how many times this dot can fit in all these different spaces, and you multiply it by that. That's why magnifying glass can actually, light things on fires, because you're magnifying all this energy, you're multiplying it into a point only that big. Same thing happens here, is as you increase the space, you're actually dividing the amount of energy it can do, and this energy is usually being brought to us in the form of heat. So if you're dividing the amount of heat, that's where you're going to get weather. And if that was kind of confusing, then let me show it to you this way. Now, you see here it's tilted away, so if the sun was on this side and the earth was tilted this way, you can see there's a lot more surface area that it's covering than there is surface area here. So there's a lot more area that the sun needs to cover up here than it does here. So because it's dispersed, remember, you divide it, and so you're going to have winter. Whereas if you're facing towards the sun, like he is right here, or if the sun was over here, there's a lot less surface area, and so the energy of the sun isn't being spread out more unequally. You multiply it compared to that one, and so right here we're going to have summer. So remember, the way to tell if it's winter or summer is if the northern hemisphere, if it's pointed towards the sun, like in this case, like if it's pointed this way, then it's going to be summer, and if it's pointed away, because if the sun's over here, then it's going to be winter. And so again, this can get confusing. Just in case it does to anybody, just make sure that you talk to me, and I'll fill you in on that. Now, the other two things we have is we're going to run into these words, and you've probably heard these words before, but might have not known what they mean. Solstice and equinox. Now, simply what a solstice is when you're dealing with the shortest day of the year, and when you're also dealing with the longest. And equinox deals with the same. So this is going to happen shortest in the wintertime, December 21st. We know it's the shortest day of the year. Longest, June 21st, and you have the longest day. That's when the tilt is the most extreme, either towards or away from the sun, and you're going to get the longest day versus the shortest day. Equinox means it's the same. So this is going to happen in the fall and the spring when you have an equal 12 hours. So that's the difference between the solstice and the equinox. And make sure you don't confuse which one's which. Alright, so that's my lesson on Earth in space. Next one we're going to talk about is we're going to talk about gravity and motion. And we'll bring up some of the stuff that we're watching in the video. Again, if you have any questions about anything we talked about, make sure that you email me and I will get you filled in. Alright, until next time, guys, take care. Bye.